So here we're going to continue on Unit 2, Lesson 7. And now we are going to go to the ketons. A keton. What is a keton? A keton, it is like an aldehyde. A keton has a carbonyl group like aldehyde. That's why aldehydes and ketones are brother and sister. They are the same. They have the same properties. So a keton, it will be like that. An R with a carbonyl, with an oxygen and another R. Not hydrogen. If it is a hydrogen here, it is an aldehyde. If it is other things, it is a keton. For example, I have this one, CH3, CO, CH2, CH2, CH3. This one, it is a keton. It is not an aldehyde. Why? Because the carbonyl, it has the oxygen, but at left and right, it is not in the end of the chain, and there is no hydrogen here. So how are we going to name this keton? Okay, naming. I'm going to go to here. Naming ketons, and we're going to take the same. I have CH3, C bound into the oxygen, carbonyl, CH2, CH2, and CH3. So I have to count how many. I have 1, 2, 3, 4, 5. So 5 it will be pentane. But because it is a keton, the E here, we're going to change it to 1, like that. Pentanone. So the E of the alkyne, the E of the alkyne, I'm going to put it here, the E of the alkyne will be changed to O on 1, pentanone. But we have to say the pentanone, what is its place? We have to number our carbons now. And we have to number our carbons that we give the carbon that has the function. The one that is holding the function, it is this carbon here. So we have to give him the list number. So we're going to number from 1, 2, 3, 4, 5. The function always has the priority. The carbon of the function has always a priority, and we have to do everything to give him the list number, the carbon that is holding the function. So this one will be what? 2 pentanone. This is the keton. It has a V shape. Why it has a V shape? Because of this oxygen here. This oxygen, it is very electronegative, and normally it has a V shape. It will be CH3 like that, with a carbon here, and we have the oxygen here, and we have a V here, a V shape. This angular here, and we have CH2, and etc. The others, another CH2 and CH3, and this angle here gives it is polar, and it gives a lot of functions. It is a V shape at the carbonyl group. At the carbonyl group, it has a V shape. Because it has carbonyl without oxygen, it is a polar. Well, we're going to go back to this, to that. It is a polar. I think all the naming stands what we said about it. So all what we said before stays the same. So now properties. What are the properties? First, ketons are polar. are polar. If they are polar, what are the forces? Intermolecular forces are dipole, 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 dipole. Dipole dipoles are the intermolecular forces in ketons. Intermolecular forces in ketons. Okay. What is the prediction? The boiling and the melting temperatures, the melting points, must be higher than comparing to the comparing to the alkynes with the same number of carbons and less than the points of alcohols with the same number of carbons. The same number of carbons. Why? Because alcohols have hydrogen bonds. This is what you have. So where we use ketones, ketones are used like aldehydes. Ketones, I'm going to write here ketones, ketones and aldehydes are very good solvents, are a very good solvent. The word that's used, for example, to remove paint from their fingers, what you are using ketones. Okay. The paint remover from the fingers are ketones. I think this is it. I'm going to stop here. Do the exercises. All the naming, all the rules that we did are the same for ramification, for all the same. I'm going to state it here. All the rules of naming are the same. Only the function has the priority. The group function has the priority. Always you have to try to give him the list number, the list order number. That's it. So we finished this one. I think if there is something, we're going to give it in another video. That's it. Bye.